and its sole purpose in life is to block ads that would come in from the internet. It does it very cleverly, and you can set it up so it will do that on all your devices on your local area network without having to change configuration on each of them individually, whether it's desktops, laptops, smartphones, game consoles, printers, thermostats, whatever you have. We're going to see it run on a Raspberry Pi. And I have a lot to talk about today, so I'll probably end up skipping some slides, but don't worry because all the slides will be posted as well as the video. And that's especially true because one of the last slides is a list of clickable links for the websites that I'll mention today. So anyway, this is what I hope to cover today, what it is, why you would want one, what kind of hardware you would need and how to put that together, what kind of operating system to use, how to get it and install it, and then the Pi-hole software itself, how to get it, install it, configure it, maintain it, and troubleshoot it. This is the opening screen from the Pi-hole site, and the whole part of Pi-hole is adopted from the black hole in astronomy, which has gravity so strong that things get near it, not even light can get away. With a Pi-hole, if advertisements get anywhere near it, they get sucked in and have no way to get out. So these are some of the features. It blocks over 100,000 ad-serving domains. As I said, it can do it on all your devices. It'll improve your network performance because fewer resources are going to get loaded over the web, which means that all those large ad images and so on won't take up your bandwidth. It'll make your web pages load faster. If you are in a metered connection, that'll reduce your usage. You can also get some statistics and monitor what's going on with it. And also, occasionally ad servers get taken over and put up malware tainted ads, which then cause people a lot of grief. I wanted to try to get a example of what it would look like with and without. This is, it was hard to get one that adequately showed it, but this is on the left without Pi-hole running and the same website on the right. And you can see that this section right here corresponds to this, and this corresponds to this. And the Pi-hole has removed these extraneous ads here, and also the ones that are down in this area from that page. I frequently make what I think are improvements to the system here at our home. My wife never notices anything, but the day after I put a Pi-hole in, she said, "I don't know what you did, but I really love my New York Times anymore. It used to be filled with ads, and now I see mostly just the articles and so on." So that, by my mind, that's a success. Raspberry Pi forms the Pi part of the Pi-hole. It's a small single board computer. It's about the size of a deck of cards or a pack of cigarettes. It was developed in the UK to teach computer science in schools in developing countries, much like the Arduino, if you're familiar with that. There are a lot of choices in what we're going to look at today, and as a result, I'm just going to talk about the choices I made. If you decide to duplicate this, you may want to go through and make different choices, and that's fine. One choice I made was to use a Raspberry Pi 3B. There are several Raspberry Pi models that have been developed, including a Raspberry Pi Zero. Now, Raspberry Pi Zero does not have all the features of the Pi 3B, but it is only $5, and Pi-hole will run on it. Operating system, I chose to use RASPBIAN Linux, which is a variety of Debian Linux adapted for Raspberry. It's available through the Raspberry Pi site, and you may choose others. It will run on many others, and in fact, Pi-hole will run on other hardware too. So as far as the Pi 3B, it really is a very, very capable unit. It has a Broadcom system on a chip in there, essentially the guts of a smartphone. It's got a quad-core ARM processor. It has all these things built in. 1 gig of RAM, has a micro SD card slot. They recommend at least 8 gigabytes and a class 4. If you're not familiar with SD cards, class refers to the operating speed, and a higher number means it runs faster. It has a built-in 100 Ethernet port, built-in 4 USB ports, a built-in full-size HDMI port. It has wireless LAN available, Bluetooth. I'm not using that in my application. There are 40 GPIO pins, much like the Arduino. There's a 3.5 millimeter jack that can output audio and or composite video. There's a digital camera serial interface and a display serial interface and a built-in graphics processor there, all on this small board, powered through a micro USB connector. They recommend 2.5 amps. Now you might have a old cell phone charger with a micro USB connector on that you could use if you want, although it may not provide 2.5 amps, but it might work fine for you. Here's a picture, a 3/4 view picture of it, and you can see here's our Ethernet jack. Here are the 4 USB connectors. Here's the audio jack. Here is the HDMI port. This is the power connector. Here are the GPIO pins at the back. This, I believe, is the camera connector, and this is the display serial connector. This is the Broadcom chip. Let's look at a top view here. You can see the same connectors as well as these 4 mounting holes. And although they're not labeled, right here is a red power light, and right here is a green activity light. If we flip it over to the bottom, this is the micro SD card slot, which is inserted from the side of the unit. So it's essentially complete except for the SD card. I bought a 32 gigabyte Samsung unit. This is larger than life size. If you're familiar with this card from your smartphone or some other use, they're about, this dimension here is maybe about 1/2 inch, something like that. Most of the SD cards come with an adapter like this. This is simply a way for you to plug this micro SD card slot into this and then have a full-size SD card, which you can put in slots that are intended for that. It's a good idea to put a case around your device. This one is made by Adafruit, which is the one that made mine. You can see the cutouts are in the right places for all the connectors. We can see 4 pins here, 1, 2, 3, 4, that are used to hold the card in there. It just snaps into place. This particular case comes with interchangeable and different colored covers. This one happens to be red, but they're really in all colors. There are other cases available in metal, in wood. There are open cases. There's covers with holes for other things. They have a display that can plug into the GPIO pins and then provide some visual output. And the Pi-hole supports that, but I do not have that feature on mine. So I had to buy the Pi and the case. I also bought their recommended charger, which is a 2.5 amp unit, and you can see the micro USB connector here. I have my Pi hardwired into my local network I needed an Ethernet cable, which I already had. And we need some other things just to get this system set up. We don't need it once it's running, but if you choose to start from scratch, as I did, you'll need a way to get that micro SD card into your computer so that you can get it loaded with the operating system. This happens to be a SD card adapter that I had already here. And when we put the micro SD card into the SD adapter and then plug that in right here, I can then plug this into a USB connector on my computer and then get access to it. So if you don't have an SD connector on your computer, or maybe you have it on your network printer or some other way, you'll need to get something like this. Again, we don't need it when it runs, just to get set up. We need to do some configuration of the unit, and so I needed a USB keyboard and a USB mouse. I happen to have these here. I plugged them into the connector on the Pi. If you don't have them available, maybe you could borrow them. As I said, we only need them temporarily. If you need to buy them, Micro Center has them for about $4 a piece. I also need a display. My monitor does not have HDMI connection. I happen to have this adapter, which has a full-size HDMI plug on this end and a VGA socket on this end, which I then plug the VGA cable in to go to my monitor. And again, I only need this for setup. So a shopping list, if you were to duplicate exactly what I did, might look something like this. The Raspberry Pi, these are prices from spring at Micro Center. They're probably similar at Fry's or Amazon or whatever. When I bought mine, the Pi was on sale for $24.99. The SD card, the 32 gig class 10, they have for $12.99, but they frequently send me little cards to get one for free. And in fact, I did get mine for free back in January when I bought my unit. The case and the power supply both are around $10. So altogether, it should be somewhere around $50. And as I said, the software is all free, so there's no additional cost. I'll just make a note here that these are electrosensitive devices, so you might want to wear a anti-static wrist guard when you're putting it together. And you should probably avoid touching the gold-plated contacts on the SD card or the anything else. So I bought my SD card bare. The Pi Foundation website recommends that you format it using the formatter program from the SD Association. Now, your SD card might come already formatted, or you could probably format it in Windows or Mac. I'm a Windows guy, and it probably would have worked, but this is something you have to do once. So I thought I might as well follow their suggestion. And this program is free. It's downloadable. It runs under Windows 10 and other earlier Windows versions. And then you just format it, and there you are. At this point, or even before this point, there were some other choices you could have done. You could buy a card that's preloaded with RASPBIAN and avoided formatting and a lot of other things. You could choose to download only RASPBIAN, or you could buy a card that's preloaded with NUBS. NUBS is the new out-of-the-box software that they have available at the Raspberry Pi site. I chose to be a masochist, and I downloaded that. It's available as a zip file. You save it to your system and unzip it. It comes out to about just over 1 gigabyte, and then copy all of those files to the SD card that's been pre-prepared. Probably don't even need to say that. Probably just prepared. Okay, at this point, it's time to put things together. And you can snap the Pi into the case, then put the micro SD card into the bottom of the Pi, and then hook up your keyboard, mouse, video, network cable, the power cable, and then plug the power supply in. If you had the monitor turned on at this point, you'll see that the Pi will boot and it'll display the noobs menu, which we'll see in the next slide. I selected RASPBIAN as the operating system to install, and it took about 15 minutes for that phase. When it's all finished, it'll come back to a desktop. You need to start a terminal session by clicking on the terminal icon in the taskbar. Now, I'm talking about, of course, the RASPBIAN desktop and the top of the RASPBIAN taskbar. This is what the noobs menu looks like when you first boot it up. It may look different when you follow yours. There may be more choices of Linux. If you'll notice on there that one of the choices out of this version is Windows 10 IoT Core. That little Raspberry Pi will run Windows 10 IoT Core on there. So if you're interested in that and not so much in Pi-hole, there you go. RASPBIAN is selected by default. That's what I did. And again, it'll take about 15 minutes to go through and do that. When it's finished, it'll be back at a command prompt. You should do a little cleanup. I'm, as I said, a Windows guy. I really don't know that much about Linux, but I'm a good direction follower. If you put these 3 commands in, it will update the version of Linux that's on there. It'll update some of the apps that came with it, and then do a little bit of cleanup. Once we're finished with that, we need to configure RASPBIAN. So we're going to type sudo raspi-config at the terminal, and we'll see some of those screens in a minute. What we're going to do is change the default password. This is for logging into the desktop on the Pi. We're going to set the host name for it. I cleverly called mine Raspberry Pi. And then we have 3 options to change it to where you are. I'm in Pennsylvania, so I set it to English US, Eastern US for time zone, and the Wi-Fi country to US. We're going to change 2 other things too under the interfacing section, and that's enable SSH and enable VNC. VNC is virtual networking, virtual network computing. And that's going to allow us to get to the desktop of RASPBIAN if we want to, using a free viewer that I have a link to at the end. And SSH stands for Secure Shell, and that will give us a terminal prompt on the Raspberry Pi. And we need to use a program on your host computer to get there. I'm, as I said, using Windows. I use PuTTY to get there. And using one of these 2 methods will allow us to go and do updating and other maintenance features on the Raspberry Pi, even without having a direct keyboard, video, and mouse on it. So let's look at some of those raspi-config menus. When you start it up, it'll look like this. Again, change user password is the first one. We'll do that. We'll then click the second one to change the host name. When we go in for the to localize it, this is where you can change the locale, the time zone, and the Wi-Fi country. The locale will give you a large number of choices of language. I picked English US. And in the other one, these have the 2 options for SSH and VNC. We won't need to do anything with the other options, but you might want to look around just to see. At this point, we have everything configured on the Raspberry Pi, and we can install Pi-hole. We only need 1 command at the terminal prompt, curl blah, blah, blah through bash. It just takes a few minutes to do that. There's no interaction required. But what you need to do is right at the end, the last screen, the part that's visible, they'll have a web login password there. You should write that down because most of our interaction with the Pi-hole is going to be through its web interface. All right, so we're ready to shut it down and disconnect our keyboard and so on. I recommend turning off the Pi by doing this at the terminal prompt, sudo shutdown -H now. There's no indication that it's shut down. The red light, as I had mentioned, that you'll see is just a power light, so that'll remain on. But if you just wait a minute or so, it should be all finished. I'm recommending this because, like your desktop or other computer, if you just yank the power cord out of the wall to turn it off, you're probably going to mess up your hard drive, and we don't want to do that on the SD card. So once it is shut down, at this point you can pull out the power adapter, disconnect the mouse, the keyboard, the video monitor, put those back to wherever you got them. We'll never need them again. What we're going to do is access the Pi-hole through its web interface, through VNC, or through a terminal session with SSH. So I said I use PuTTY to get an SSH session, and we're not going to go into it today, but PuTTY does support key pairs, and this will let you make a nice complex long password on the Pi, but not have to type it in all the time. You can just, using PuTTY, double click on the session and it will log you in automatically. When we enabled SSH, it also enabled an SFTP server, which we can use to transfer files back and forth if you need to do that. For example, if you end up using key pairs to log into it, that's how you can get the public key over to the Raspberry Pi. I should have mentioned before that when the Pi got hooked into your network, your DHCP server, probably on your router, assigned it an IP address. Hopefully that showed up in the screens. You need to record that because we're going to access the web page via this command on a web browser, and I'm not sure if it's my unfamiliarity or whatever, but I'm unable to access it through the name. I need to use the IP address. So if you didn't write it down, you can't find it. There's a place to go on your router, I'm sure, which will show you which devices are connected and what their IP addresses are. So we'll need to use this URL and the password that we wrote down during installation. This is the first screen you'll see. Now, I modified the display slightly on Pi-hole to make it a little bit easier to look at. So on a widescreen monitor, it'll look a little different, but the exact same stuff is there. The first four things that show up are kind of a summary. So the red block says that we're blocking 106,964 different domains. What this means is that if a device on your network asks for one of those domains, it's lied to. It's told that the IP address is not where it really is, but it's given the IP address of the Raspberry Pi. On this particular day, there were 14,000 queries made from all my devices. The Pi-hole blocked 912 of them, which was about 6.4%. So it's a sizable amount, and it's hard to say that my system is 6.4% better that day, because some of the things that are blocked are images, perhaps larger images, and anyway, it's a good thing. So the next section down shows the number of queries for a DNS resolution over the last day, and you can see that some of them happen all hours of the day at night. You know, I have things that are plugged in and running, you know, my thermostat, my game console, my whatever. Even if I'm not using the computer, there are queries going on all the time. This particular day, there were some in the morning and a peak at 4 in the afternoon. This is just of interest. It doesn't, you don't really need it for anything. The next section is query types over time, whether they were IP version 4 or IP version 6. again, it just shows you what percentage of the total were one or the other. Again, it's just for curiosity's sake. The next section is where they were forwarded to. Now, these are requests for domains that were not blocked by the Pi-hole. It's just telling you who eventually told the device where that domain is located. I have 2 upstream DNS servers configured, and we'll get to that real soon. This is just giving us of the 100% in any given hour, which percentage went to which upstream server. The green is local, which means the Raspberry Pi already knew about it and didn't have to ask anybody else. The next section is on top domains and top advertisers. Top domains are domains that were not blocked. You can see on the chart there, they're in green. They're in order by decreasing by the number of requests. Google at the top and others. On the right, the top advertisers, these are domains that were blocked. And you can see some of the usual suspects there. Again, it's in decreasing order by the number of hits. The next section is top clients. Now, a client is who asked to have this domain resolved. And although I'll mention how you can configure this in a different manner, all of my clients still ask my router to resolve a domain name. The router is configured to ask the Pi-hole. So all of the requests that the Pi-hole sees comes from my router, and that's why almost all of them come from this particular IP address, which is my router. The ones that say localhost, these are applications on the Pi-hole that needed a domain and made a request. Before we go on to the next one, I'll mention at the very bottom of this first screen is a little note with the version of the Pi-hole software. There's 3 main pieces. Each version is separate. If there's an update for one of them, there will be a note shown there, and it'll say update available. Okay, the next screenshot is from this second icon on the left-hand side, and this is a log of what happened with recent queries. So it's in order decreasing by time. So most recent is on top. It's blocked by 10 on this screen, but you can block it by a larger number if you wish. There's a large number that it has records on here. It tells you the time of the request, if it was version 4 or version 6, what domain was asked for, who asked for it, and again, this is all going to be, for the most part, my router. And then either green for it was forwarded on, or red if it was blocked. If it was forwarded, it may look like this. If it says OK cached, it means that the Pi-hole already knew what it was and didn't need to send it anywhere else. The last column here, action, gives us a useful button. So if it's a green line where it was forwarded and it should have been blocked, you can click this button and it will blacklist that domain, which means it won't get through again. If you see one that was blocked, this convenient button will whitelist it, which means it will not be blocked the next time. So this is a really convenient way to whitelist and blacklist domains. The next one down shows us our whitelist. Now, this is the system comes with some entries already in the whitelist, and if you add any, they'll show up at the bottom here. On the right-hand side is a trash can. That's where you can get rid of one if it's in there and it shouldn't be in there for some reason. The next one down is blacklist. I do not have any extras added to the blacklist, but they would show up here, and if you need to add one, there's a place at the top for you to fill in a domain and then add it. The next section lets us disable the Pi-hole. This would be useful for troubleshooting. You can either disable it permanently, which means until you re-enable it, or for varying amounts of time. And it's real convenient to pop in there and say for 5 minutes, and then do whatever you need to do to see if the pie hole is causing a problem. And then if you forget, it'll turn itself back on after 5 minutes or whatever time you settle. The next one has a thing to maintain your lists. So you can click this button to update the list. Ordinarily, it does it once a week, I think, on its own schedule. But if you feel a need to update it manually, you can click it there. Query the ad list. You can type a domain in here, and it will show you if it's in the block list or not. The next one, tail, gives you a more detailed list of what's actually happening there as far as what the query is for, where it came from, who it was forwarded to, what answer came back, and so on. It's really for curiosity's sake or troubleshooting if you need to. The next one is for settings, and at the top it just gives us some information about the Pi hole and its networking interface. It'll always be ETH0 on a Raspberry Pi. This is the IP address that mine was issued, and this was the host name that we entered. The Raspberry Pi has a DHCP server, which you can enable if you want to use its advanced features. I like the one on my router, and I do not have this enabled. If you did enable it, this allows you to set up a DHCP lease, which means that you can type in MAC address for a device in here, an IP address and host name, and it will always assign that IP address whenever it sees that MAC address coming along. In my router, that's called DHCP reservation, and I do that on all my devices. The next thing we need to worry about is upstream DNS servers. So again, the Pi doesn't really know where anything is, so it can't translate a domain name into an IP address unless it's already been given an answer. So you'll have to tell it where to go to get an authoritative answer about a particular domain. You might be using a public DNS server. I use OpenDNS. It has a lot of features. It's free for home use. It can block categories of domains like ones with hate speech or that promote guns or liquor or pornography, or there's any number of categories in there. Or Google, you might be using those because they're faster than your ISP's DNS server, but in case you are using your ISP's DNS server, you need to make a note of that somehow through your router screen or some other way. And you can put it in this upstream DNS server screen. I happen to be using OpenDNS, as I've said, so let's go back here. So I've checked both of these boxes for primary and secondary IPv4. If you wanted to use your ISPs, this would be where you would put it, and then you would check it, these two boxes. There are advanced DNS settings that we don't need to worry about, and the log size, it tells you what the size is. It gives you an opportunity to get rid of them. You can also disable logging here. If you do, you won't see any statistics anymore. The block lists, if you expand that plus sign, you'll see a list of the 7 block lists that it talks to. It takes all of these, reads all the entries in there, combines them, removes duplicates, and that's where that 106,000 comes from. If you choose not to use one or more, you can uncheck the box here. If you have an address for another one that you'd like to use, you can add that here at this point and save it and update it. The next area is on an API that would let a program on your network get some statistics. I don't use that, and you probably won't either. Okay, the web user interface. This is where I've unchecked this for this demonstration. Again, they say it's helpful when using large screen. This is also where you can change the units of temperature on the status screen, and I've changed mine to Fahrenheit. In the system administration part, you can restart the Pi-hole, you can restart just the DNS server. There's another place you can flush the logs. The bottom of this, there are two plus signs. If we expand those, you can get some statistics on the FTL, which is short for faster than light. It doesn't mean anything to me. The teleporter at the bottom gives you a chance to save and or restore your whitelist and blacklist if you've customized it and you want to move it to another Raspberry Pi somewhere or give it to a friend or whatever. The last part is the help indicator, and that goes on for a long way. The very top of it talks about the status display, and I've amplified this status display from the corner here. It has 3 lines. It shows whether it's active, offline, or starting. It shows the temperature of the Raspberry Pi. You'll see I have a fan in my case. It took it down about 15 degrees from this. It shows us the processor load on the Pi. Mine is never very big. And finally, the memory usage. Mine is never very big. So one thing about the IP address, I said you need to know what that is. It also needs to be fixed. So you need to reserve that IP address somehow, probably either with a DHCP reservation or to assign it outside of your system's DHCP range, and then make sure it's always the same because this is a server. So I said I use FiOS. My router has reservations. This is the bottom of that page. You can see that here's our Raspberry Pi name. This is the IP address for it. Here's its MAC address, and it's static as opposed to dynamic on here. So it'll always be given that address whenever it's asked for it again. Okay, we need to configure it to be your DNS server. You can, and maybe you would want to at the beginning, if you just want to practice with this, take an individual device, and I can't tell you how to do that because it's different for everyone. Go into the characteristics of your network interface. You might want to write down what's there already, and then change it to the IP address of your Raspberry Pi Pi-hole, and then practice with it a while. If you get to the point where you want to use it for everything, you can go in and do it on your, probably your router or whoever's assigning DHCP answers. There's usually places for a primary and a secondary, and the way that works is, supposed to work is that the primary is asked every question, and only if it does not answer does it go to the secondary one. So I have OpenDNS as the secondary one. This will allow me to take out the Pi if I need to, or if it's dead, then my network will continue to work, but it might be a little bit slower. So here's a screenshot from my router, and right in this section right here is where the primary and secondary DNS servers are listed. The first one you'll probably recognize as my Raspberry Pi, and the secondary is the OpenDNS server, one of its addresses. All right, I'm going to try to really speed through this last little bit. If you're not familiar with how DNS works, here's your client machine. Maybe you're sitting there in a web browser and you ask for www.godaddy.com. If the machine has already been there and it knows it, it will not ask anybody else because it knows it. If it doesn't know it, it will ask your local DNS server, which is probably your router. It has a cache too of frequent request, recent request, and if it knows it, it'll just return it. If it doesn't, it'll send it on out and up probably to your ISP's DNS server or an open DNS server, a public one if you have it. It has a cache too, but if it doesn't know, it'll start at the root. If we're looking for www.godaddy.com, it'll ask one of the root servers, where is the com server? The root server will answer back, and it will ask then the com server, where is godaddy.com? It'll probably answer back, I don't know, but if you ask this guy, he'll know. And when you ask him, he says GoDaddy's at this address. He'll return it here. He'll return it here. He'll return it here. And then things will go on as happens. What we're going to do is stick our Pi hole right in here, break this connection right here. All the requests will come through here. This will send its requests on in that way. So requests are either passed on through or they're blocked. As I mentioned before, if they're blocked, it'll return the address of the Raspberry Pi here, and we'll see what happens with that. If it's blocked and it asks for a resource from that, whether it's an image or JavaScript file or whatever it is, the Raspberry Pi will answer it and then either return perhaps a page like this, which will give you a chance to whitelist it. You notice here there was a request for doubleclick.net. You could whitelist it right there. Or it might be a block like this from when your browser is saying it's trying to close the page. That's a key that that Pi-hole has interceded. All right. Troubleshooting. I have had some problems. I quoted,
you have about 5 minutes.
Thank you. I'll talk even faster. I use Windows Media Player to rip audio CDs, and the Pi-hole was blocking attempts to get the metadata for the track from it. I used the query log to identify that, whitelisted it, everything was fine after that. We also have a Roku video streamer with a PBS subscription, and trailers would show up fine on our TV, but every time I asked for a full episode, it would crash it. I identified that as the Pi-hole, whitelisted it, and that's fine. Again, you can try disabling it temporarily if you need to, and then go through and whitelist various domains that appear to be blocked. If they fix it up, then you can just leave it blocked. If they don't fix it, you can whitelist it or remove it from the blacklist. All right, I mentioned that there's a cache in your browser. You'll need to probably clear that, or it'll continue to lie to you and say there's still a problem even though you turn the Pi-hole off. I keep a batch file which has only this one line in it on my Windows desktop. This is what Windows uses to clean out the DNS cache there, and if I'm troubleshooting, I need to do this to complete the fact that the browser will then re-ask the OpenDNS server what it is. Let's see, if there's a notice about updating it at the bottom, you need to make a terminal session to the Raspberry Pi and put this command right here, pi-hole-up. It only takes a minute or two to do that updating. That's a good time to also do the updates and upgrades on RASPBIAN. These come out at irregular times. Maybe John Kennedy could tell you when RASPBIAN should be updated. I really couldn't tell you. If you do it once a month or so, you should be fine. There's also a Win32 disk imager that I have a link for on the links page, which you can use to clone the SD card to make an image of the entire card, just in case it gets damaged. And I tend to be the nervous sort, so I've done that. And I already mentioned teleporter, so you can use that to go to another Pi or to reset it if you think you've messed up the whitelist or the blacklist. Shutting down the Pi, I already mentioned you're likely to corrupt the disk if you just pull the plug. This is, if you start a terminal session, you can put in this sudo line. This is the command if you need to restart it for some reason. You could also go into start a VNC session and reboot it from there. Again, the red light is only a power light. The green light indicates activity, so definitely don't pull the plug if the green light is blinking. And this is the slide with the links on. Again, this will be posted, and this can tell you everything you need. There's a lot of community help both at the Raspberry Pi site, at the Pi-hole site, and if you have a question, I'm sure it's available there. Here's a picture of my unit. You can see there's a fan on the top. I caught it just at the right time when the green light and red light are on. And you can see we do not have any other keyboard or mice or video plugged in. It's just the network cable, power cable. And that would be it. So thank you for listening.
Okay, thank you, Don. Very interesting program. As I said, we're going to take about a 10-minute break. As I said, I didn't get any questions during the presentation. So what I'm going to ask you is if you've got a question for Don, type it in the chat box, and we will send it to Don, and he'll give you an answer. Most of the chat is you'll see Don was that people appreciate it and lots of good information. So I'm going to ask Jerry to start the music, share his desktop and shot the music, and we thank Don for making an excellent presentation. And we'll be back in about 10 minutes to hear about home automation security. Thank you very much.
Thank you.
Jerry, you got the music going? Don, you can stop sharing your screen. Okay.